In this unit, we will be talking about our trigonometric identities. And notice that we are told that a trigonometric identity is an equation involving trigonometric functions that is true for all values for everywhere the expression in the equation is defined. The identities help evaluate functions, simplify expressions, verify identities, and solve equations. You will want to put all of these identities on a note card of some sort, or you can go back to your reference page, either one. So for number 1, we are told to use the quotient and reciprocal identities to find the value of each function. So this is really going to be something where we have to know those trigonometric identities. So it's a good idea to have your reference page in front of you. So we know that secant of theta is going to be equal to negative square root of 30 over 3, and we need to find cosine. So going back to our reciprocal identities, we are told that cosine of theta is equal to 1 over secant of theta. And so that in turn is going to be equal to 1 over negative square root of 30 over 3. And that means reciprocal. So here we are going to go do our reciprocal. And so we're going to have negative 3 over the square root of 30. We do need to rationalize here, rationalize the square root of 30. And so our final answer is going to be negative 3 times the square root of 30 all over 30. And of course, those 3's and 30 will cancel. So we have negative the square root of 30 all over 10. All right, so now let's look at number 2. We are told that tangent of x is the square root of 2 over 4. And cosine is negative 2 root 2 over 3. And we are told to find sine of x. So keep in mind, again, using your identities, we know that tangent of x is going to be sine x over cosine x. Now what we're going to do is fill in with these values that we know. So in place of tangent x, I'm going to put the square root of 2 over 4 equals sine x, I don't know. That's what I'm going to try to solve for, over cosine x, which is negative 2 square root of 2 all over 3. So now we have something that we can do some kind of cross multiplying. I would try to simplify one side first and try to make that look a little bit better. Or again, cross multiply, either one. Let's just go ahead and cross multiply since there's so many numbers here. So I'm going to multiply here to here. So that's going to be the square root of 2 times negative 2 root 2 over 3 is equal to 4 times sine x. And notice here, that's the same thing as square root of 2 over 1. So when we multiply those square root of 2's, that is going to give you the square root of 4, which simplifies to 2. So I have negative 2 times the 2 that comes from here. So that's going to be negative 4 over 3 equals 4 sine of x. And then we would divide both sides by 4 to get sine by itself. And over here, I'm going to divide by 4, which is the same thing as multiplying by 1/4, either way. And so notice that sine of x is going to be negative 1/3. Okay, so for number 3, we are asked to find secant of beta. We're told that cosecant of beta is 7/3. So automatically, I know that sine of beta is going to be 3 over 7. We know that reciprocal. And then cotangent, well, cotangent, we know that to be cosine of beta over sine of beta. And so here we're getting a little bit closer. We can now fill in the blanks. Cotangent of beta, notice we're told that that value is negative 2 square root of 10 all over 3 is equal to cosine of beta, we don't have a value for that, over, and we now know sine of beta is 3/7. And again, we can do our cross multiplying here. And when we do that, we have 2 square root of 10, negative 2 square root of 10, times 3/7 is equal to 3 cosine beta. And over here on this side, we can simplify this up a bit. We can put that over 1 if we need to. And then we have here negative 6 root 10 all over 7 equals 3 cosine beta. But then I can divide or multiply by 1/3 if you want to. That 1/3 to cancel out your 3. And then this 3 will cancel into 6, leaving 2. So notice that we end up with cosine of beta is going to be equal to negative 2 root 10 all over 7. Okay, now we're going to talk about the trigonometric identities, and we're looking at Pythagorean identities. And with those Pythagorean identities, that's going to be these 3 up here that you really need to make sure you have on a note card or keep that reference sheet in front of you, because we will be using those. Now with the Pythagorean identity, we are told that we need to find cosine and tangent, and we're given sine of theta is negative 1/3. So we do need to keep in mind here that we're over in, let's see, we've got a different quadrant. Notice they're telling us that cotangent is negative. So if we go back and look at our signs, A, S, T, C, that we have sine is negative, and then cotangent is also negative. So that tells me that we are in quadrant 4. So cosine is going to be the only positive value. Now we also know that sine squared, we're going to use this first identity up here. So sine squared theta plus cosine squared theta is 1. In place of sine, I'm going to put negative 1/3 because we're told that is its value. Now don't forget about keeping that squared. That is important. And so we're going to have a good equation here to solve. 1/3, negative 1/3 all squared is 1/9 plus cosine squared theta equals 1. And I'm going to subtract 1/9 over. So cosine squared theta is going to give me 8/9. Now I need to take the square root of both sides, and we will get plus or minus here. But we were told that we're in the 4th quadrant, so we know we're going to take the positive version. So cosine of theta is going to be the square root of 8 over the square root of 9. And if you simplify the square root of 8, you have 2 root 2 over 3. So now we know what cosine of theta is. Now we need to go find tangent of theta. That was the next thing it wanted us to find. And you have a couple of ways to do this. So we know that tangent of theta is sine of theta over cosine of theta. And so we were told that sine of theta was negative 1/3. And we found that cosine is 2 root 2 over 3. And so this turns into dividing fractions. Remember, as easy as pi. You're going to flip the second and multiply. So I'm going to flip over this second fraction. We need to multiply by that reciprocal. And notice here that those are going to cancel. I have negative 1 over 2 square root of 2. And to go ahead and rationalize this, you need to multiply top and bottom by just the square root of 2. And so we have tangent of theta to be negative square root of 2 over 2 times 2. So that's going to give us 4. Okay, for our next problem, we need to find tangent and we need to find sine. And let's look at what we're given. We're told that secant And notice secant here is positive and sine is also positive. So if we go over here to check our sines, if secant is positive, so that implies also cosine is positive, so those are gone. And then for sine to also be positive, we are in the first quadrant. So we have to be in quadrant 1. Okay, so talking about our identities here, with tangent, I know that tangent squared x plus 1 is secant squared x. And so I'm looking for tangent x. I know secant x, so let's go ahead and substitute that in. I have tangent squared x plus 1 equals 6 over 5 all squared. So I have tangent squared x plus 1 equals, and if we square 6, we get 36. We square 5, we get 25. And now we need to subtract 1 from both sides. So we have tangent squared x equals, and let's see, 36 over 25 minus 1. Remember that 1 really becomes 25 over 25. So it looks like we have 11 over 25. And then we're going to take the square root of both sides. And do remember, again, we do have plus or minus, but we are in the first quadrant, so we're going to take the positive. And this is going to be the square root of 11 over a square root of 25, which is going to be square root of 11 over 5. So now we know what tangent is. Now we need to find sine. And so a couple of ways we can do that. Now I know tangent, if we go back to earlier, is going to be sine of x over cosine of x. So if we substitute in our values, we have the square root of 11 over 5 equals sine of x over, well, I know cosine is the reciprocal of secant, so that's going to be 5 over 6. Now we can do some cross multiplying, and so if we do that, we have 11, square root of 11 times 5 over 6 equals 5 times sine of x. And now I'm going to multiply both sides by 1/5 to get rid of that 5. So that 1/5 cancels with 5. This 1/5 is going to cancel with that 5. So I have the square root of 11 over 6 equals sine of x. Okay, with these problems, we are going to be using our cofunction and even odd identities. And so notice here that we have to find cosine of pi over 2 minus theta. So if we notice up above or even on our reference page, we are told that cosine of pi over 2 minus theta, that is equal to sine of theta. And so after we know that, based on what we're given, we can go back up to our even odd identities. So I know that sine of negative theta is equal to negative sine theta. So it looks like we can just take this negative here and we can move that out. So we're going to have negative sine of theta equals negative 0.97. And so if we divide both sides by -1, notice that we end up with positive 0.97 is equal to sine. And so that in turn also tells me what cosine of pi over 2 minus theta is equal to. It is going to be the positive 0.97. Okay, for doing the same idea, same basic thing, look at number 7. You're told that cotangent of alpha minus pi over 2. So if we knew something about cotangent or tangent here, that would help. So cotangent of alpha minus pi over 2, we really need to rearrange this. If we're looking at our identities, we see that we really don't see much of that. So we do need to swap some things around. So first looking, let's go see what tangent of negative alpha is going to be equal to. And if we look up in our formulas, we see that that's equal to negative tangent of alpha. And so now I'm going to replace over here our value with what we're given. And that's going to be equal to negative tangent of alpha. So we see that 2.36 is equal to tangent of alpha. Now, I know that's going to be related to cotangent. And so up here, I'm going to rewrite this because we have tangent of theta is equal to, notice this is cotangent of pi over 2 minus theta. So it's backwards to what we are given. So to fix that, then we need to switch some things around. So first thing I would do here is take cotangent, and I really need to pull out that negative there and say, well, that's equal to pi over 2, because that's just going to change where our negative is going to be. And I know that then in term from what I know from cotangent's identity, that negative is just going to come out and be negative cotangent of pi over 2 minus alpha. And again, that's coming from right up above at our even and odd identities. So now I know that cotangent, negative cotangent of pi over 2 minus alpha is really going to be equal to tangent of theta, or alpha in this case. So I can move my negative here. I'm going to move that negative back over here. And so notice that that's going to mean that cotangent of pi over 2 minus alpha is going to be equal to the negative of tangent of alpha. And we found the tangent of alpha to be 2.36. Okay, this problem's like the above. Notice our angles are swapped, so we're going to have to fix that. We need to flip those angles. So that means we're going to have secant of negative pi over 2 minus beta. And that's going to be equal to, here, if we go ahead and just bring down the other side, it's negative 3.62. And again, from our even and odd identities, that tells me this negative can move out. And that's going to be negative secant of pi over 2 minus beta is equal to negative 3.62. So notice those negatives do cancel, and I'm left with secant of pi over 2 minus beta is equal to 3.62. Now we're looking for cosecant of negative beta. So over to the other side, we see that secant of, and this is going to be our cofunction identity, that secant of pi over 2 minus beta is equal to cosecant of theta, or in this case beta. All right, so here we need negative cosecant, so I'm going to multiply both sides by a negative. So that's going to give me secant of pi over 2 minus beta equals negative cosecant beta. And again, I'm just multiplying by that negative to get what we need. And then here, again, I'm just going to bring down this other side, negative secant of pi over 2 minus beta. And now using our even and odd identities, notice that tells me I can move that negative in. And so that's going to be cosecant, oh, and I wrote cosine, cosecant of negative beta. And finally, that's going to be what we need. So here, making this substitution, we have negative 3.62 is going to be equal to cosecant of negative beta. All right, number 1 on your homework, you're told that tangent of beta is the square root of 15 over 10, and they are asking you to find cotangent. And we know that cotangent of beta is going to be the reciprocal, so we know that's going to be 10 over the square root of 15. We definitely need to rationalize here. And so we're going to have 10 times the square root of 15 all over 15, and then we can divide a 5 out of each one of those. So that's going to be 2 root 15 all over 3. All right, moving on to the next, number 2. We're told that cosecant of theta is going to be negative 4 square root of 6 all over 3. We need to find sine, and so again we know sine of theta is the reciprocal. So now a reciprocal does not change the sign of the term, so please leave that sign. If it's negative, it's going to stay negative, so don't change that. We do need to rationalize. So we have 3 times the square root of 6 all over 4 times 6, because again here that does give me the square root of 36, and that in turn reduces to 6. And now I can cancel the 3 with the 6. That's going to leave a 2. And so I have negative square root of 6 all over 4 times 2, which is 8. Okay, moving on to the next. Here we're told that cotangent is negative 1/2 and sine is 2 root 5 over 5. And we have to find cosine. So all 3 of these terms would be related with cotangent of x is going to be equal to cosine of x over sine of x. That's one of our identities. Now we will sub in here, so I have negative 1/2 is what I'm given. Cosine of x is what I'm looking for, and sine of x I was given is 2 square root of 5 over 5. Here's going to be where we come back and cross multiply. So negative 1 times our denominator, we're going to have negative 2 square root of 5 over 5 is equal to 2 times cosine of x. And then again, I'm going to divide both sides by 2 or multiply by 1/2. I would rather just multiply by 1/2 since I have a fraction over on this other side. It makes it a little bit easier to navigate those numbers. And now after we do multiply by that 1/2, notice that this 2 and this 2 do cancel. And so and our 2's cancel over here. So I have negative square root of 5 over 5, and that is equal to cosine of x. All right, so now number 4. Again, we're told secant and we're told tangent, and we've got to find cosecant. Well, let's see, what all do we know? I know secant, that is going to be the reciprocal of cosine, so I know cosine of alpha is negative 7/9. And let's see, tangent, cosecant, I know that is going to be the reciprocal of sine, so I know that's 1 over sine of x. So let's see, I know cosine and tangent and sine. So let's put these together with the identity that tangent of alpha is equal to sine of alpha over cosine of alpha. And now fill in what we know. We know tangent is negative 4 square root of 2 all over 7 equals, I don't know what sine is, that's what we're going to find. And then cosine we were told is negative 7/9. Now let's do our cross multiplying here. So I have negative 4 times the square root of 2 times 7, negative 7/9 equals 7 times sine of alpha. I'm going to multiply both sides by 1/7. And so we've got some canceling here. I know sine of alpha. And then over here, I'm going to cancel these 7s. I have the negatives to cancel. So it looks like I'm going to have 4 square root of 2 all over 9. However, that is sine of x. We needed to find cosecant, so we're going to have to do the reciprocal. So that means we're going to have 9 over 4 square root of 2 equals cosecant of x, or alpha. And so now we have to rationalize, multiply top and bottom by the square root of 2. And so in the numerator, we have 9 times the square root of 2 over 4 times the square root of 4, which is 2. So we're going to have 9 times the square root of 2 all over 8. Okay, for our next problems, we need to use the Pythagorean identities. And notice that we're given sine tangent. We are seeing that cosine is negative and sine is positive. So we're going to be over here in quadrant 2. So let's see, what do we know? We know sine squared of theta plus cosine squared of theta equals 1. And so we're looking for sine, so I'm going to keep sine squared. I'm going to substitute in negative 3/4 in place of cosine, and don't forget your squared. And so this is going to be sine squared theta plus, and if I square this, remember you square the numerator and the denominator, so that's going to be 9 over 16 equals 1. So sine squared theta is going to be 1 minus 9 over 16, and so that's going to be, so I'm going to have 7 over 16. Take the square root of both sides, and again we do have plus or minus, however we figured out that we are in quadrant 2, so we're going to take the positive, and that's going to be the square root of 7 over 4. Now that we have sine, we do need to go back and find tangent, and we know that tangent of theta is sine of theta over cosine of theta. And so now we're going to sub in tangent of theta. It's going to be equal to, and we found sine to be the square root of 7 over 4. We were given that cosine was negative 3 over 4. And so now we're going to divide our fractions. And remember, it's going to be, you keep the numerator, you change your division to multiplication, and you flip your second fraction. Keep, change, flip. Those cancel, so you have negative square root of 7 over 3. Okay, so again, we're given some trigonometric identities. We have to find cosine of y and tangent of y. And let's see what quadrant we're in. And so let's see. Cosecant is negative, so that throws out those first two quadrants. And cotangent is positive, so that means we are in the third quadrant. We've got to find cosine and tangent. Now this portion here, cosecant, that means that I know that sine of y is negative 2 over the square root of 6. And so I can use that because I know sine squared of y plus cosine squared of y is equal to 1. So I'm going to substitute in. So I have negative 2 over the square root of 6, all squared, plus cosine squared of y equals 1. And so if I square this, I have 4 over 6 plus cosine squared of y equals 1. And again, I would subtract over. And so let's see, I'm going to have 2 over 6 when I subtract here 4 over 6. So that's going to give me 2 over 6, which is going to give me 1/3. And I need to take the square root of both sides. And so I get plus or minus again, but this time, notice we're in quadrant 3, so we're going to keep the negative. And so I know that's going to be the negative 1 over the square root of 3, which is negative square root of 3 over 3. Now we have to find tangent, and so we're going to again use the same idea. We know tangent is sine over cosine. So I'm going to start that again. Tangent of y is going to be sine of y over cosine of y. And we knew that sine of y was negative 2 over the square root of 6. Cosine of y was negative square root of 3 over 3. And so again, we're dividing fractions. So we're going to multiply by the reciprocal. 3 over negative root 3. And so here, let's see, we're going to have that to be positive, and in the numerator we have 6. In the denominator we have the square root of 18, and the square root of 18, that will reduce, so I have 6 over 18 is 9 times 2, so 3 square root of 2. 3 cancels into the 6, leaving 2 and a root of 3. So now I have 2 over the square root of 2, and again I needed to rationalize here, so I'll multiply top and bottom by root 2, and so I'm going to have 2 root 2 all over 2, and so finally just square root of 2. Okay, for our next problem, we're told that we need to find tangent and we need to find cosecant. And we're told that secant is 3 over 2, so automatically that means that we know cosine of beta is 2 over 3. And we're told that tangent is negative, so if we go check our quadrants, it looks like we're probably going to have to be in quadrant 4. And so let's see, if we want to know tangent, and we've gotten this, so we know that 1 plus tangent squared beta is equal to secant squared beta. And so we can plug in, we have 1 plus tangent squared beta is 3 over 2 all squared. And so here, let's see, what are we going to get? We're going to have 9 over 4. We're going to subtract that over. So we have tangent squared beta is equal to 5 over 4. And again, we're going to take the square root. We're going to have plus or minus. So it looks like tangent here, tangent beta, and we're going to have to take the negative because, again, we're in the 4th quadrant. It's going to be negative square root of 5 all over 2. So we found our tangent. And cosecant, we know, is the reciprocal of sine. So based on the information we're given, we really could go find sine because I know tangent of beta is sine beta over cosine beta. And so tangent was negative root 5 over 2 equals sine of beta, which is what we're trying to find, over cosine, which is 2/3. So again, that's going to set up a cross multiplying problem. So that's going to be 2/3 times the square root of 5, and that's all going to be negative now, equals 2 times sine of beta. I am going to multiply both sides by 1/2. And so we have sine of beta is going to end up being, those 2's cancel, so negative square root of 5 all over 3. However, we were needing cosecant, so I need that reciprocal. And it looks like we might have to do some rationalizing there. So cosecant of beta is going to be negative 3 over root 5. And so whenever we rationalize there, we're going to have negative 3 root 5 all over 5. Okay, our next problem, we are going to use the Pythagorean identity that has cotangent squared x plus 1 equals cosecant squared x. And let's see, we're going to plug in, but we also need to know what quadrant we're in. So let's go look at our signs. Cotangent is positive and secant is negative, so we have to be in the 3rd quadrant. And so let's plug in. We're told 2 square root of 6 all over 5 all squared plus 1 equals cosecant squared x. So when we square this, we are going to square the 2, so that's going to give us 4. If we square the square root of 6, that is 6, so 4 times 6, that's going to give us 24 over 25 plus 1 equals cosecant squared. Now we have to add before we try to do the square root, and so that's going to give us 49 over 25 equals cosecant squared x, and we are taking the square root of both sides. We do need to include that plus or minus, but we know that we are in the third quadrant. We're talking about cosecant, so it's going to have to be negative, and the square root of the top over the square root of bottom. So we see that cosecant is negative 7/5. We need to now find cosine. Since we're given cotangent, then I know tangent is going to be 5 over 2 root 6, and I know that tangent of x, again, is sine over cosine. And so let's fill in what we know. Tangent, we're going to replace that with 5 over 2 square root of 6 equals sine. Well, sine's the reciprocal of cosecant, so that's going to be negative 5 over 7, and then that's all over cosine x. So again, we're where we can do our cross multiplying here. So if we cross multiply, I have 5 times cosine x is equal to negative 5/7 times 2 square root of 6. And just like earlier, we are going to multiply both sides by 1/5 to get rid of the 5 over here. And so we have cosine of x is equal to, and we're going to do some canceling, to have negative 2 square root of 6 all over 7. Okay, now we're going to use our even and odd and cofunction identities. Now, the first thing that we're asked is to find cotangent of y minus pi over 2. And so that looks like that might be a little bit backwards to what we need. So let's go ahead and figure out what we can do with this. I know that tangent of negative y is equal to negative tangent y. And so here I'm going to fill in with what we're given, equals negative tangent y. And so I have negative 0.9 is tangent of y. So let's go over here to the other side and notice that we have cotangent of y minus pi over 2. Well, that's a little bit backwards. We know that that is going to be, if we take out our negative, cotangent of negative pi over 2 minus y. And then we know that negative would need to come out. And so that's going to be negative cotangent of pi over 2 minus y. And so I know from that identity here that that's going to be equal to, negative tangent of y. And so back up here, we have both those values. Well, since I know it's negative tangent of y, so here I have 0.9 is going to be negative cotangent of pi over 2 minus y. All right. Okay, so looking at just this portion here with sine, we know that sine of pi over 2 minus theta, that is equal to cosine of theta. And so I also know that all of this sine is equal to 0.34. That is cosine of theta. Now we also know that cosine of negative theta is equal to cosine of theta. So very quickly we see that cosine of negative theta has to be 0.34. Okay, so for our next one, again, this one is written backwards. So we're going to start out with saying, well, I know that this is equal to, and if I do the opposite, that's going to give me pi over 2 minus x. I'm factoring out that negative. And so, again, that's still equal to negative 1.06. I am going to move this negative to the outside, so I have negative secant of pi over 2 minus x. That's going to be equal to negative 1.06. Sorry, that negative really doesn't do anything. Let's go back and remove that because that's just like sine. If you do the sine of a negative theta, that's the same thing. So over here, let me clear that up for just a second. In your identity, secant of negative angle is equal to the same thing as secant of the positive angle. So basically, these two things are the same that we have. So I know secant of pi over 2 minus x is negative 1.06. Now, let's go ahead and look at cosecant x. And I know that sine or secant of pi over 2 minus x is equal to cosecant x. So this is going to make a really quick just substitution here. So I know I'm going to have negative 1.06 is equal to cosecant x. Okay, for our final homework problem, here we have cotangent of negative alpha equals negative 2.61. So we know that cotangent of negative alpha is really equal to negative cotangent of alpha. And so here we can make this substitution, negative 2.61 equals negative cotangent of alpha. So we see that cotangent of alpha is 2.61. And so here we also are given that tangent of pi over 2 minus alpha. We know that's equal to cotangent of alpha. So a nice little substitution here. We see that tangent of pi over 2 minus alpha is equal to 2.61.